Another SVTA talk. It was between MOQ and MQA. You guys will get the MQA talk. So, Sean, work at YouTube. I'm going to go through these quickly. I'm leading the QoE group at the SVTA. Are you guys familiar with MQA? Pretty much everyone outside of the QoE group is probably not. Media quality assessment. It's something we've been working on since last spring, and it's about to be published. The SVTA document, I actually have a comment out to change the name. It was going to be 2110, which is a really bad name because of a commonly, referenced, completely unrelated protocol. But the core concept is we wanted a way to communicate media quality information. So think perceptual quality scores, VMAF, PSNR, SSIM, UVQ, bring your own score, IMAX scores, between various entities within a streaming workflow, live or VOD. It actually started as an extension of CMSD. So the problem's multifaceted. We typically look at bitrate at the network level, whether it's on the client side, whether it's the CDN side, the ingest acquisition side, as a proxy for quality. We don't really want to throw compute resources at linear streams or high volumes of streams to actually decode and compute these scores at scale. That's really expensive, time consuming. And we want to know, regardless of network conditions, where in the chain perceptual quality, especially in a pre-media package workflow, perceptual quality degradation is introduced. So there's a triangulation of root cause analysis play as well. Obviously, we had the ad tech talks. That adds another whole layer of complexity where it's a different transcoding pipeline. You might get jarring perceptual quality dips, and you want to see how your users actually respond to that. Do they really care? Are you able to spend less money transcoding ads, or will you lose users or viewership or engagement if you do? So the solution is what we've worked with various standards, with various existing standards to extend. CMSD on the HTTP side, SEI for really your SRT, even satellite acquisition, or anything transmitting H.264 and H.265. That'll be at the layer that we just dove into with the mock talk earlier. Dash ingest, I don't know if anyone's actually using that, but we did add it to the spec. And then ERTMP, which Kirk talked about, we got into at the end here in hopes that if ERTMP continues to be that band-aid before mock, we could take advantage of some of these new features and functionality. So VQA types are defined. I just listed a few of them here. There's a number of industry companies that have brought their own scores. Bitmove and VQA, UVQ is a YouTube one that's open sourced. AWS, et cetera, plus all your standard open source ones. There's a particular taxonomy. That's how this spec works. So if you work with a particular metric here, or have a preference for a VQA metric, make sure you reach out soon so we can get it added, because it's going to be a while before we update this again. You can communicate information about the video, even the temporal reference, the audio, and whether or not the score applies to both video and audio. There's a number of other key parameters that I didn't list here. MQA use cases, this is what keeps coming up, like, okay, that's cool, but why would you do it? The obvious one is the dashboard. You want to see, your bit rate, your other engagement metrics, kind of superimposed over your VQA scores. But some really interesting kind of feedback loop automation, client-side AVR logic. Why, if you're in your middle rendition, would you upshift to your highest rendition in your player if you have the bandwidth available, if you're not really getting a bang for your buck in terms of perceptual quality? It's like a 95 VMAF score versus a 96. Should you really waste that extra bandwidth? This is all additional logic that can be added to the player. Intelligent origin failover. I think the GNL group did a really cool demo with this using MQA. The idea is you have a multi-origin live stream or VOD, two different packagers, two different encodes, two different packagers. One might be experiencing packet loss, the other might not. As far as your CDN is concerned, could have strong connectivity to both. 200 served. Why would you want to favor the poor quality video? So you can now use these HTTP headers and favor the first, use it as a failover. Transcoding optimization. So for the ingest workflow, acquisition side. So I have an example on the next slide, or the last one, showing the MVPD workflow where we get multiple copies of a MES stream from a provider live event. Why should we be transcoding both? Why don't we pick the best, the best quality without having to look at packet loss, or maybe sometimes if there's third-party aggregators that feed us, we don't even see the packet loss. They've re-encoded, poor bit streams. This way we can, pick the correct the correct stream regardless. And the final one, monitoring by exception. You see those operators in the broadcast facilities. The multi-viewers are really expensive to run. Running UVQ or VMAF or what have you is really expensive to run across hundreds or thousands of streams. What if you only monitor when you're signaled of a quality degradation? That's the idea. I think I'm at time, but there's an example here of how this could be used in an end-to-end workflow in really throughout all those different protocols. So let me know if you have any questions about it. Thanks.
Thank you so much.